potassium and chloride, two more electrolytes to look at. To figure out why they're important in the body, what do they do? That's what we're trying to look at in this video. Let's start with potassium. Now we know potassium is going to be a cation. It's a positive ion. We have the symbol as K. That goes back to its original Latin form again, but it is potassium. Now hopefully you remember from previous videos, potassium has a higher concentration inside or outside the cell. If you're thinking inside, you're right. Potassium will have a higher concentration inside the cell, while it has a lower concentration outside the cell. That gradient is established and maintained in your body. What is it maintained by? That's the sodium-potassium ATPase or sodium-potassium pump. It's meant to oppose sodium. So potassium, high concentration inside the cell. Sodium was a high concentration outside, remember. Now potassium can also help a little bit with the fluid balance in your body. Usually if you have lower levels of potassium, you'll then end up having some secretions of aldosterone kick in. Remember, aldosterone was from the adrenal glands, helps with salt retention, therefore fluid retention. So potassium can help out a bit with fluid retention. The only problem is the kidneys are going to kick potassium out when they retain sodium. So what ends up happening here is when your body's reabsorbing sodium from the kidney tubules, as they reabsorb sodium, for every one sodium, they then kick out a potassium. This is one of those positive ions, which means that you lose on average about 200 milligrams of potassium a day. Thankfully, your body can recoup that pretty easily, but that's also why then the adequate intake for potassium is higher than both sodium and chloride. The adequate intake is pegged right around 4,700 milligrams per day. That's partly due to the fact that you're constantly losing it through sodium reabsorption. All right, so why is potassium important in the body? Well, we already mentioned how you regulate it, but why? We know nerve impulses. We talked about the idea of depolarization, repolarization. So a quick recap there. In your nerves, in your muscles, you need sodium to depolarize the membrane. So basically going to a positive charge. And then potassium repolarizes the membrane as it flows out of the cell. So as all those positive potassiums leave the cell, the internal membrane potential drops back to negative. So it's important in the membrane potential for nerve impulses. You're also going to need potassium for platelet formation and platelet functionality. Platelets, those little tiny things in your blood, those fragments, they're going to help clot and basically block up any damage to your blood vessels. Need potassium for protein synthesis, energy metabolism, acid-base homeostasis. There's a ton of things that potassium will help with. When you start thinking about the acid-base balance and buffering, well, potassium is a positive cation, which means it's dealing with the positive negative charges of the solution. Well, potassium needs to be regulated like anything, so it's to be kept in a certain range. If you end up going too high or too low, you end up with what's called hyperkalemia or hypokalemia. In the case of hyperkalemia, so too high, and again, that whole kalemia, back to the original Latin terminology there. But hyperkalemia, in that case, it can actually cause interference with your heart rhythm. Well, think back, why? We know that potassium is needed for the repolarization of electrical impulses. Your heart functions based on electrical impulses. So it makes sense there. Hypokalemia, well, in that case, Now, hypo, it's low potassium. And this one a lot of times is tied to high sodium. Because if you have too much sodium, then in that case, your potassium is being exchanged through as you keep moving through more and more. So a lot of times high urination, you get heart palpitations, that's all from hypokalemia. Hyperkalemia, the one with too high, was the changes in your heart rhythm because of the depolarization, repolarization. Well, another thing to look at is how do you get potassium? Well, it comes from your diet, of course, but fruits and vegetables are going to be your best sources, specifically fresh fruit and vegetables. The reason being is potassium is very soluble. It's very easy for it to dissolve into water. So if you're cooking the fruits or veggies, then that cooking heats it up and the potassium goes into solution, into the water you're using. Same thing for canned fruits or vegetables. The canning process has to heat up for safety purposes. That heating can cause some potassium to go into solution. So the best is fresh fruits, fresh vegetables. Second best is frozen, because the frozen haven't gone through as much heating. You'll probably heat them to warm them up, but it won't necessarily have the same heating as if you're fully cooking them. So it's one of those things where it's good, better, best. Best is fresh, better is frozen. But at least any potassium that you are ingesting has a greater than 90% absorption rate in your small intestines. So pretty much whatever potassium you get in, it's going to be absorbed through your small intestines. All right, that's potassium. Let's switch over to chloride. Now, chloride or chlorine molecules, we're looking at these chloride molecules as the main anion in your extracellular fluid. Anion meaning negative. So Cl, chloride, is going to be a negatively charged anion. So all that fluid around your cells, that is your extracellular fluid. And a lot of times you're going to find chloride ions with sodium ions. Makes sense, sodium chloride, salt. So sodium is in high concentration outside the cell. Chloride is high concentration outside the cell. Your adequate intake for chloride is give or take about 2,300 milligrams a day. So just like sodium, it's much lower than potassium. And most of that intake you get is coming from the salt you ingest. And once you have ingested and absorbed, your body is really good at hanging on to those chloride molecules. So you'll keep them and keep using them over and over. Now, chloride might help a little bit with fluid balance, but that's really mainly potassium and the actual sodium helping there. What chloride is really good at helping with is mucus production and mucus secretions. If you look at the respiratory and digestive systems, they both are going to have mucous membranes lining them. Those mucous membranes are helping to move substances along, but also helping to trap foreign particles. So trapping pathogens. So both the respiratory and the digestive systems are going to have dedicated chloride channels. By having these dedicated chloride channels, it's then going to allow for the ease of the water into the mucus to make sure the mucus is the proper consistency. Because you don't want the mucus to be too thin, you don't want it to be too thick. It has to be the right consistency to help without hindering the processes. Another helping hand, the pancreas. Your pancreas will make pancreatic juices, pretty much digestive enzymes to help in your small intestines. Chloride ions are very helpful in producing those pancreatic juices. Now, your chloride ions also can help with the acid-base balance. There are negative particles, so they can help out with the charge there. Help out a little bit with the balance of positive and negative. But one thing to keep in mind, if there's free hydrogen ions that bind to chloride ions, you've made HCl, hydrochloric acid. Now, hydrochloric acid can be a very strong acid, and that kind of works right into our GI tract. Our digestive system, our stomach, produces hydrochloric acid. This hydrochloric acid is going to help with activating enzymes. It'll help with breaking down food molecules. And it's also going to help with being against pathogens, more antimicrobial, if you'll say. It's going to destroy them because of how acidic the nature of your stomach will be. Your stomach quite often falls in a pH of 2 or 3. That's really acidic. Hydrochloric acid can even drop down to a pH of 1 at times. So as you're looking at the pH of your stomach, think, well, how does it not destroy or damage itself? That comes in with mucus. The mucus from those chloride channels is coating the entire stomach and helping protect it from the hydrochloric acid, also from chloride that you have. All your nutrition is balancing and helping these. But where you can really tell how much chloride has an impact in your system is looking from the disease side. If you look at cystic fibrosis, that's a genetic disease that has a malformation of chloride channels. Now, the malformation of the chloride channels means they can't work properly. One of the big problems there is that means they cannot help with mucus production. Unfortunately, cystic fibrosis patients can suffer from very thick mucus secretions. These thick mucus secretions can start to clog up and cause problems in the respiratory passages, impeding airflow and causing problems with breathing and oxygen absorption. Other problems that can occur in cystic fibrosis patients are looking at the potential for malnourishment, looking at the issue of having problems with nutrient absorption working properly. You can also look at, in that same train of thought then, is malnourishment, not enough nutrients, growth is slower or completely stunted at some points. All of this because of the chloride channels not functioning properly. Just goes to show you how important chloride can be. So your electrolytes. Talked about potassium and chloride here. We've already talked about sodium in a different video. All these electrolytes are really, really important because they help with balancing off your body's fluids. They can help with hydration. Side note here of looking at how Gatorade was made. Gatorade was founded down at the University of Florida, the Florida Gators. Their football coaches and the hot summer practices decided there's a problem here because our players are just collapsing, they're crashing in this heat. They went to some scientists on campus and said, hey, can you figure out what our players need so they don't crash, they don't collapse of all these heat problems? They figured out they needed electrolytes. They made a drink with higher amounts of electrolytes. The players started doing better. They went on to win one of the bowls the following year. That is how Gatorade started. The multi-billion-dollar industry was started by some football coaches asking some scientists, how do you help these players? So Gatorade, Powerade, Pedialyte, all these sports drinks are focused at trying to replenish potassium, chloride, sodium, zinc, all these different electrolytes your body needs. Now, as far as which one's best, that's always an argument. Every company says theirs best. But look at the labels. Read the nutrition label on each one of those drinks and judge for yourself. What do you need versus what extra is in there? How much of the different sugars are in there? Do you need that much sugar in a drink if you try to replace electrolytes? But even more importantly, do you need the sport drink? If you're not exercising for an extended period of time, sweating profusely, losing all this fluid, losing all this electrolyte, That's when you need the sports drinks. If you're just going for a walk and not even sweating, you probably don't need a sports drink. Just grab some water, rehydrate. Water really is a great source. So all these electrolytes, vitally important, but you gotta make sure you balance them. Balance them out with water in your body. Until the next video.